we've seen how to make confidence intervals for means, and now we're going to see how to create them for proportions. And so you might remember that proportion data follows the binomial distribution, and it turns out that that can be approximated by the normal distribution as long as two conditions are met. We need n times p and n times 1 minus p to be at least 5. And in this image here, you can see how if that happens, then we could approximate this with the normal distribution. And you can play around with different values of p and n and see how this would look approximately normal. And in this case where we're looking at proportions and we want to use our sample proportion to come up with an interval where we have some level of confidence that the actual population proportion lies, the formula that we would use to do this is p bar, our sample proportion, our sample p, plus and minus a z value that will come from our confidence level, times our standard error. And technically this isn't our standard error from before, it's an estimate for it. So previously, our standard error for the proportion was the square root of p times 1 minus p all over n. Well, now I don't know what p is. I'm trying to estimate p using my sample proportion, p bar, and so I'm going to replace the p's with p bar and put a hat over that sigma. So this is an estimate for my standard error. And p bar is my sample proportion. It measures the fraction of successes in the sample. And so let's take a look at exercise 3 here. It says the IRS reported that 85% of individual tax returns were filed electronically in 2017. And a random sample of 240 tax returns from 2018 was selected. And from this sample, 187 were filed electronically. So we're looking at the proportion that were filed electronically. So our point estimate is going to be the sample proportion. So in our sample, how many were filed electronically? Well, in our sample, 187 of them were filed electronically, and there were a total of 240 in our sample. So our sample proportion would be 187 over 240. And here, x is the number that were filed electronically, that's the 187, and n is the 240, and so our sample proportion is x over n, 187 over 240. Part B asks for the margin of error. So the margin of error is going to be our z value times this standard error estimate, which is the square root of p bar times 1 minus p bar all over n. And if we look at this formula, we already know what n is, we already know what p bar is, so what we need to figure out is this z value. So let's see, if we look down to part C, it looks like we're going to be making a 90% confidence interval. So we want the z value for a 90% confidence interval. So that means our alpha is 0.1, so the area of both tails adds up to 0.1, so alpha over 2 should be 0.05. So each tail has an area of 0.05. So if I want to find my z value, I would do norm.s.inv of the total area to the left here. Let's see, 0.9 plus 0.05 would be 0.95. And so that would be our z value. And so let's use that to find our margin of error. So our p bar, I'm just going to type this in, was 187 over 240. And let's see, our z value, so our z alpha over 2, we said that this should be norm.s.inv of 0.95. And we want to find our margin of error. First, let's maybe find our standard error estimate. Technically what we're finding is an estimate. So this would be the square root of p bar times 1 minus p bar, with that 1 minus p bar in parentheses, divided by n. And all of that fraction is inside of the square root. So there's our standard error. And so our margin of error will be the product of our z-value times our standard error. So our margin of error is about 0.044. So to get our confidence interval, we'll start at p bar and add and subtract this 0.044 value. So let's see, our LCL would be p bar minus this margin of error, and the UCL will be p bar plus this margin of error. And it's always good to pause here and make sure our numbers make sense. So remember that our proportion, p, can't be bigger than 1 or smaller than 0. It has to be somewhere between 0 and 1. It has to be between 0% and 100%. And so if I got an LCL or UCL that was smaller than 0 or bigger than 1, that wouldn't be helpful, and it might mean that I made a mistake. But here, these are both between 0 and 1, which is good. And we could write them as percents. Let's see if I have Excel write these as percents and show a few more decimal places. This tells us that the proportion of taxpayers who filed electronically we think is between about 73.5 and 82.3%. And so this let us use our sample proportion, our p bar, which was about 78%, to come up with an interval where we're 90% confident that the actual proportion of taxpayers who filed electronically lies. And the year before, they had said that 85% of tax returns were filed electronically. 85 is outside of our interval. 85 is bigger than our UCL. And so it looks like the proportion of taxpayers who filed electronically, it looks like that has gone down since the previous year because 85% is not in our interval.